Spontaneous versus non-spontaneous. So we know what the spontaneous means in a social context. That's not what we're talking about here. A spontaneous process in science means that it will happen without ongoing outside intervention. So if we have a simple mechanical system like this, it's easy to see how the system tends towards lowest potential energy. If this guy lets go of the rope, what's going to happen to this weight? It's going to fall, and hopefully he'll move, because it looks like it's going to land on his foot, but hopefully he'll move out of the way. It's going to fall. Why? Well, it has higher potential energy here, and when it falls to the earth, it has lower potential energy, and that's how nature works. It's going towards lower energy, right? So in a chemical system, we need to have some equivalent thing to the potential energy so that we can see what's going to be spontaneous or not. So we need a chemical potential that's going to predict the direction of the system. So when we look at sodium chloride dissolving in water, well, we can observe that the direction of spontaneous change is that the solid dissolves. We can observe that. So that must mean that the solid here has higher chemical potential than the dissolved ions. But what exactly is that chemical potential? It's important to remember that spontaneity is different than speed. A reaction can happen it's thermodynamically spontaneous, but kinetically it could be very, very, very slow, right? But it's still spontaneous. A catalyst would increase the rate of the reaction, but it will not have any effect on a non-spontaneous process. However, a non-spontaneous process is not impossible. Non-spontaneous processes happen all the time, but they do require external energy to be put in. They don't happen on their own. You have to make them happen.